All right, so we're finishing off 7.7 and we are looking at or starting with parallel and orthogonal vectors. All right, so looking at parallel and orthogonal vectors. Two vectors are parallel when the angle theta between the two vectors is 0 degrees or 180 degrees. If theta is 0 degrees, the vectors point in the same direction. And if theta, I said if theta is 0 degrees, I think I said it right. Anyway, if theta is 0 degrees, the vectors point in the same direction. If theta is 180 degrees, the vectors point in the opposite direction. So let me draw that just so we can get a visual. All right, so that's a visual on how they would look if they are parallel. All right, so two vectors are orthogonal when the angle between the vectors is 90 degrees. It's another way of talking about perpendicular, but they believe orthogonal best describes these vectors versus using perpendicular. So, all right. And of course, if I scroll up too fast, let me know. IFF is if and only if, shorthand. So I didn't make a mistake there. It says two non-zero vectors, V and W are orthogonal if and only if V dot W is equal to 0. And then another point. All right, and so because the dot product of 0 to V is going to be equal to 0, the 0 vector is orthogonal to every vector V. Are we going to do this vector projection to V? All right, yep, we'll do that. Okay, so all right, so are the vectors v equal to 6i minus 3j and w equal to I plus 2j orthogonal? So, only way we'll do that or know that is if the dot product of the two is equal to 0. So we'll take 6, multiply it to 1. You know, those are our I terms. Or I guess you would say we had I terms, or those are our A's. And then we're going to add that to negative 3 times 2. 6 plus negative 6. And that is 0. All right. So since we got 0 there, V and W are orthogonal. Any questions so far before we go to the next one?
Not from me, no.
That sounds good. Sounds good. All right. So next piece. All right. Trying to see a good way of explaining this. These are orthogonal vectors, F and G, vector components, method of finding every vector. Finding the components of F plus. All right. So talking about projecting the vector onto W has to do with a force. I'm trying to find a general way of explaining it without putting force into it. Reverse the process by determining a particular region, another part of this force. So put these two called vector components of F. Notice the method of finding F1 and F2. Okay. Let's see. Just have to use force. All right, so we talk about projection of a vector onto another vector. So a method used to find the components of force that is applied that should be is applied, is to project a vector onto another. Okay, that's good right there. Um, mm,
Okay, so that first word in red there, that's not jacked up. That's supposed to be a small W like that.
yes, sir. That's PROJ, regular size. Then we have a subscript W, and then regular size B.
I just want to make sure. Thanks.
Yeah, thank you for the clarification. I appreciate that because I'm pretty sure someone else had that same question. I guess I could have I'll draw another diagram to make sure we get it better. Rationale. Won't let me. Okay. All right. So we're talking about a projection of V onto W. You see what vector they're actually doing the measurement on and the force. So a better diagram is if we were looking at let's see, a boat. Let's see if I can draw this right to make it look halfway decent. It's kind of like a boat, right? All right. So what we're talking about here, let's say if we had this example of a boat and it's on a ramp and you're trying to pull it up the ramp, where there are two forces that are being applied to this boat. So you have one coming down on it that's pressing it up against the ramp, and then you have gravity that's pushing it. Well, gravity is pushing it up against the ramp, then gravity is pushing it down the ramp as well. So to be able to calculate how much force is being put on this boat in order to get it, up the ramp. That's what we're talking about when two different vectors are being applied. You can find the force, the total force, by projecting one vector onto the other. And so if you have all the numbers, then you'll be able to calculate that. But that's just an example application of which you have the type of scenario of two different vectors being applied to one scenario or one situation. Once again, you have one force, what is the same force, but the force is being applied to pushing the boat onto the ramp and then pushing the boat down the ramp. So, yeah, I know you guys can't wait to figure out how to do that.
Oh, joy.
I'm already Googling it.
Wait, is that the arc?
You know what? When I was drawing it and I was thinking about how round I was making, I was like, you know what? This could be close to the arc.
I was going to say something, but I'll just let you go.
So let's look at the projection.
That's about my skill level as far as building it too.
You knew this was coming and didn't forewarn. All right, so let's look at the formula to help us to do this. So the vector projection of W onto V and W are non-vector vectors, projection. Okay. Take the dot product. All right. Trying to write this as good as I can. So we're talking about the projection of V onto W. Notice that all this right here is a scalar. You know, it's just a solid number. Talking about the dot product of V and W. And then down bottom, you have the magnitude of W squared. So once again, this piece is just a number. That's a scalar. And then here is your vector, vector W. All right. So let's try it out. All right, so if 2i plus 4j, if v is equal to 2i plus 4j, w is equal to negative 2i plus 6j, find the vector projection of v onto w. All right, so the first thing we can find is v dot w. So it'll be 2 times negative 2 plus 4 times 6. Negative 4 plus 24. So we're looking at 20. I guess I can put it in a box. All right. Next, we're looking at the magnitude of W squared. So we're looking at the square roots. Is minus 2 squared. Oh yeah. W squared. We can take the short route. I don't have to do that. That's gonna be 2 squared plus 6 squared. But that is squared as well. All right. So that square and square root cancels. So So that'll be 4 plus 36, which is 40. All right, so before we go any further, make sure we are okay. Oh, no, let's take purple. All right, yep. It's going to be 20 over 40. We're going to project that onto or multiply that to negative 2i plus 6j. So that'll be 1/2. And do our distribution. So that's going to be negative I plus 3j. All right, let's see what the next one is. Last one out of this section, then we should be good. Questions on anything I've done so far?
No, I'm good.
All right, sounds good. Okay, I might be right all this. All right, before I keep going, we're setting up for this last formula. The vector components of V, let V and W be two non-zero vectors. Vector V can be expressed as the sum of two orthogonal vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. So that sets us up to be able to go here. All right. So we're going to use this to be able to decompose vector V. All right, so V is equal to V1 plus V2. The vectors V1 and V2 are called the vector components of V. The process of expressing V as V1 plus V2 is called the decomposition of V into V1 and V2. So in other words, you're going to break down V into two components, two vector components. All right, so let's look at this example that applies here. All right, so we want to let V1, not V1, let V be equal to 2I plus 4J, and let W be equal to negative 2I plus 6J. Decompose V into vectors V1, V2, where V1 is parallel to W and V2 is orthogonal to W. All right. So now, well, I'll give you a chance to write before I get started. All right, so in this process, now this one is not going to be as long as it could be because we're not starting from scratch. Notice that these are the same two vectors from the last problem. Going back to, we got 2I, 4J, negative 2I, 6J. And so 2I, 4J, negative 2I, 6J. So we have the same two vectors. The first step in this process is to find, the projection of V onto W. And we already found that, which was negative I plus 3J. So we won't go through that process again. So that's the first step of this, to find that. If I'm not mistaken, that is V1. Yep. And all right. So that is V1 for us. So now find V2. I wanted that to be red, so I'll keep. And so V2 is going to be V minus V1. plus 4J. Now I'm gonna get down here. All right, go ahead and combine your like terms accordingly. Don't forget this minus sign. Let's go to each term that follow. So it's going to be 3I plus J. And that's going to be V2. And that's pretty much it. That's all they wanted you to do. So V1, negative I plus 3J. And then V2, 3I plus J. And if we were to add these together, we would get V back. So basically all we did was decompose V. All right. Questions on anything I've done?
I've got none.
Okay. And as always, some questions may show up after you get in there and start working on things, and that's understood. So next class, I'll open the floor for questions, see if anybody generated any, throughout the weekend. Remember, there are only 3 major sections that I want to make sure or ensure that we cover before we leave out. There's 11.1 through 11.3 dealing with series and all the good stuff like that, series and sequences. There you go. Next week, we have a full week. The week following, we're not meeting at all, so don't forget that. That's Thanksgiving week. So give you that off completely. And then we'll go from there. I need to post chapter 7's test review and test, I believe. I don't think I've done it yet. So we'll do that. And then fourth test will be on chapter 11. And that'll be your fourth test. I know y'all said y'all couldn't wait for the final, so I had to figure out what we're gonna do for that. So yep. We'll go from there. Questions, concerns, or comments? I don't know if anybody missed. I think y'all missed that last thing I said. But anybody?
No, I heard you.
Does the test review count towards our grade? I can't remember.
They are extra credit if you decide to do them, but if you do not do them, they will not be held against you.
Is it extra credit towards a degree?
Well, I don't. My reach that's a little further out past my reach, sir. I can make it towards your test.
No, I meant like as in to a certain extent.
Well, it'll go towards your test. I can add points to your test. But not because when you say your degree, you're talking about
Yeah,
the
I know.
diploma?
You thought like, yeah, I need to work on that. But yeah, I was just asking about like, is it gonna bump up our grade in math, or is it
Yes.
just gonna go to the test?
Well, see, the thing about it is the major part of your grade will be your test. So the way my class is set up as far as your grading is concerned, if you have a test average of at least an 85 and you did all of your homeworks, then that'll take you up to an A.
Okay.
So then I think if you want a B, then you have to at least have a 75 test average and your homework's done.
Okay.
So, and when I look at your homeworks, I would say at least a 75 on your homework if you're trying to get, a decent amount of credit for them. So at least if you're trying to get your grade to be bumped up and stuff. So I think as far as passing, I think the lowest grade, and I have to go back and check the lowest grade that you can get on your test would be a 60, but you have to do your homework, of course. So if
Okay.
yeah, if your average is 60 on your test, you can still pass the class with a C.
Okay. All right.
All right.
That's nice.
Not a problem, not a problem. I see your heads clap. So
Come
yeah.
on, 60.
Anything else, anybody else before we close out? All right, all right. So you guys have a great weekend. Be safe, and I will see you on Tuesday.
Thank you.
Thank you, thank you.